Hi students, welcome back. Today we are going to discuss simple oxides from P block. Are you ready? A binary compound of oxygen with the other element is called oxides. As already stated, oxygen react with most of the elements of the periodic table to form oxides. In many cases, one element forms two or more oxides. The oxides vary widely in their nature and properties. Oxides can be simple. Example, magnesium oxide, aluminum oxide. But oxides can be simple or mixed. Example, Pb3O4, Fe3O4. Simple oxides can be classified on the basis of their acidic, basic or amphoteric character. Oxides can be classified as simple or mixed. Simple oxides can be again classified on the basis of their acidic, basic or amphoteric character. An oxide that combines with water to give an acid is termed acidic oxide. An oxide that combines with water to give an acid, that is known as acidic oxide. Example, sulfur dioxide, Cl2O7, CO2, N2O5. For example, sulfur dioxide combines with water to form sulfurous acid H2SO3. SO2 plus H2 gives H2SO3. So, sulfur dioxide is known as acidic oxide. An oxide that combines with water to give an acid is termed as acidic oxide. Okay, example SO2, Cl2O7, CO2, N2O5. Then you should write the equation of SO2 plus H2 gives H2SO3. As a general rule, only non-metal oxides are acidic, but oxides of some metals in high oxidation state also have acidic character. Example, Mn2O7, CrO3 and V2O5. Only non-metals oxides are acidic in nature, but some metals in their oxides, they are in high oxidation state, also behave like acid. Example, Mn2O7, CrO3, V2O5. The oxides which give a base with water are known as basic oxides. Example, Na2O, CaO and BaO. For example, calcium oxide combines with water to form calcium hydroxide, that is a base. Okay, so simple oxides can be classified on the basis of their acidic, basic or amphoteric character. So, in general, metallic oxides are basic in nature. Some metallic oxides exhibit a dual behavior. They show characteristics of both acidic as well as basic oxides. Such oxides are known as amphoteric oxides. They react with acid as well as alkali. Okay, amphoteric oxides means they react with both acids and alkali. Okay, for example, Al2O3 react with acid as well as alkali. Al2O3 react with HCl, we will get AlH2O6 3 plus 6Cl minus. Al2O3 react with NaOH plus H2O, we will get 2Na3AlOH 6 times. So, Al2O3 is an example of amphoteric oxides. Study this equation very clearly. There are some oxides which are neither acidic nor basic. Such oxides are known as neutral oxides. Okay, some oxides which are neither acidic nor basic, such oxides are known as neutral oxides. Example, carbon monoxide, nitric oxide and nitrous oxide. Ozone is an allotropic form of oxygen. It is too reactive to remain for long in the atmosphere at sea level. At a height of about 20 kilometers, it is formed from the atmospheric oxygen in the presence of sunlight. This ozone layer protects the Earth's surface from an excessive concentration of UV radiations. Okay, that we already know. Preparation. When a slow dry stream of oxygen is passed through a silent electrical discharge, conversion of oxygen to ozone occurs. The product is known as ozonized oxygen, 3O2. When silent electrical discharge is passed through oxygen, it converts to ozone. It converts to ozone. 3O2 gives 2O3. Since the formation of ozone from oxygen is an endothermic process, it is necessary to use a silent electrical discharge in its preparation to prevent its decomposition. Kando? The formation of ozone from oxygen is an endothermic process, so it is very necessary to use a silent electrical discharge in its preparation to prevent its decomposition. Why the silent electrical discharge is needed for the conversion of oxygen to ozone? Okay, study very thoroughly. If concentration of ozone greater than 10% are required, a battery of ozonizer can be used. If the concentration of ozone greater than 10% are required, then we can use the battery of ozonizer. And pure ozone can be condensed in a vessel surrounded by liquid oxygen. Pure ozone can be condensed in a vessel surrounded by liquid oxygen. The next properties of ozone. Pure ozone is a pale blue gas, dark blue liquid and violet black solid. Ozone has a characteristic smell and in small concentration it is harmless. However, if the concentration rises above about 100 parts per million, breathing becomes uncomfortable, resulting in headache and nausea. Ozone is thermodynamically unstable with respect to oxygen. That is very important topic, since its decomposition to oxygen results in the liberation of heat. When ozone is decomposed to give oxygen and heat is also liberated, it is an exothermic reaction. So delta H is negative. And an increase in entropy, that is delta S, is positive. These two effects reinforce each other, resulting in large negative Gibbs energy change. For its conversion to oxygen, delta G is equal to delta H minus T delta S. Delta H is negative, delta S is positive, then delta H minus T delta S, that means that is negative. So delta G become negative. Okay. It is not really surprising, therefore high concentration of ozone can be dangerously explosive. Ozone is thermodynamically unstable with respect to oxygen, since its decomposition into oxygen results in the liberation of heat. So delta H is negative and delta S is positive. Delta G is equal to delta H minus T delta. So delta G is negative. Therefore, high concentration of ozone can be dangerously explosive. To the ease with which it liberates atoms of nascent oxygen, ozone undergoes decomposition to form O2 plus nascent oxygen. It acts as a powerful oxidizing agent. For example, it oxidizes lead sulfide to lead sulfate and iodide ion to iodine. PBS react with ozone, we will get PbSO for lead sulfate plus oxygen. 2 iodide ion, 2I minus, react with ozone. In the presence of water, we will get iodine plus 2OH minus plus O2. So, we can say that ozone is a powerful oxidizing agent. Ozone undergoes decomposition to form O2 plus nascent oxygen. It oxidizes lead sulfide to lead sulfate and iodide ions to iodine. Okay, study these equations very clearly. Next topic also very important. When ozone reacts with an excess of potassium iodide solution buffered with the borate buffer. When ozone reacts with an excess of potassium iodide solution, it is buffered with the borate buffer. Then iodine is liberated. It can be titrated against standard solution of sodium thiosulfate. This method is used for the estimation of O3 gas. How is O3 estimated quantitatively? This is also very important topic. Experiment has shown that nitrogen oxides combine very rapidly with ozone, and there is thus the possibility that nitrogen oxides emitted from the exhaust system of supersonic jet aeroplanes might be slowly depleting the concentration of ozone layer in the upper atmosphere. Experiment have shown that nitrogen oxides, particularly nitric oxides, combine very rapidly with ozone, and there is the possibility of nitrogen oxides emitted from the exhaust system of supersonic jet aeroplanes might be slowly depleting the concentration of ozone layer in the upper atmosphere. Nitric oxides that emitted from the exhaust system of supersonic jet aeroplanes must react with the ozone to form NO2 and O2. So it might be slowly depleting the concentration of the ozone layer in the upper atmosphere. This is also very important topic. Another threat to this ozone layer is probably posed by the use of freons, which are used in the aerosol sprays and as refrigerants. Okay? The two oxygen bond length in the ozone molecule are identical. That bond length is 128 picometer. And the molecule is angular as expected with a bond angle of about 117 degree. It is a resonance hybrid of the two main forms. Okay, then you should draw these two diagrams. Okay, resonance structure of ozone. It is used as a germicide, disinfectant, and for sterilizing water. It also used for bleaching oils, ivory, flour, starch, etc. It acts as an oxidizing agent in the manufacture of potassium permanganate. The uses of ozone means it is used as a germicide, disinfectant, and for sterilizing water. It also used for bleaching oils, ivory, flour, starch, etc. It acts as an oxidizing agent in the manufacture of potassium permanganate. Why does O3 act as a powerful oxidizing agent? Okay, that you already studied. How is O3 estimated quantitatively? Okay. Okay guys, this is an important topic. So you should study clearly. The remaining topic we will take in the next class. Until then, bye.